Assalamualaikum and hi everyone. So this is chapter 2 on the linear system. Okay, so now system. Right, so what is system? So linear system means, so it consists of several linear equations. For example, you have x plus y equal to 1. 2x plus 2y equal to 2. This is just for the example lah. So this is system. So you have two linear equations. So that is linear system. But let's say you have x, y, z. Let's say you have variable x, y, and z. So you need three equations. So you have to remember lah, two variable, two equations, three variable, three equations. This is just for example 2x equal to 2, 3x plus 3y plus 3z equal to 3. Okay, so two variable, two equation, two variable, two equations, three variable, three equations. Okay, so in this chapter we want to solve the linear systems, or we want to find the value of x, y, or maybe z, depends on the variable, by using several methods. So first we will use Gauss Elimination Method. So you have already learned in EM1 chapter 7 Gauss Elimination, and also we can use a Gauss Elimination Method with five-voting. And then we have the LU method. So LU method is Doolittle, Thomas, and also Koleski. And the last one is iterative method, Jacobi, and also Gauss Seidel. Okay, right. Okay, so the linear system I have mentioned just now. So the method of the error can be computed by using the norm. This one as a norm. So let's say the sum of the magnitude, or norm 1. So this is the formula, the summation for the absolute value for the V. And then by using the norm 2. So this is the formula for the norm 2. So you square root, you square and then you square root. And this is the most famous one, maximum norm or infinity norm. So this is the formula, the maximum number of the error. Okay, depends on the questions. So this is the method we can use to solve the linear system. So we have the elimination method, LU method, and also iteration method. Right. So first, in the elimination method, consists of two methods, Gauss elimination and also Gauss elimination with five-voting. Okay, first Gauss elimination method. Right, so you have to put your matrix in terms of augmented matrix. After that, apply the ERO, elementary row operation, that you have learned before. Apply the ERO. So you have to reduce your matrix until you get this form. The diagonal should be 1, so the other will be 0, and then ABC. So ABC is the answer, is number lah, any number. So you have to reduce your matrix by using the ERO until you get this form. The diagonal should be 1, and then below the diagonal should be 0. So the upper one is okay. Okay, so after you get this form, and then we apply back substitution to get the answer. Okay. For example, we have these linear systems, and we want to find the value of x, y, and also z. Okay. Right. So first, we have to put our matrix as the augmented matrix. So we have 1, 1, negative 1, 2, negative 1, and 3, negative 1, negative 4, 1, 3, 7, 6. Okay, So you have this augmented matrix. 1, negative 1, 2, negative 1, 3, negative 1, negative 4, 1, 3, 7, 6. Alright, okay. Right, so you need to reduce your matrix on by using the ERO methods, and the diagonal should be 1. Okay, now our focus is column by column. So the first column, the diagonal is already 1. So you don't have to do anything lah. So this one is already 1. So next focus is the below the leading one. So the below the leading one should be 0. So in the ERO, there is only 3 techniques in the ERO. This is just a refresh what you have learned before. So we have 1, a change of row. Okay, and then the second one we have a multiplication. And the last one we have addition. So we have 3 techniques in the ERO. So why you apply the multiplication? Because we want to make the element as 1. Why we apply addition? Because we want to make the element as 0. Okay, so the formula for the addition, K is the constants. This is the row leading one. And then this is the affecting rows. This is the leading one. The row for the leading one, where leading one located. And this is the affected row. So this is just a flashback lah, what you have learned before. Right, okay, back to the questions. Okay, now our focus is we want to make 2 and also negative 1 as 0. So because we want to make it as 0, so we have to apply addition operation. Okay, so apply addition. So the formula is KR1, K leading 1, this one plus with the affected row. Okay, so let's say we focus on 2. So K, this one is 2. So K will be negative 2. Okay, leading 1 is at the row number 1, and then plus the row affected 2 at the row number 2. So we are using this formula. And for the negative 1, so negative 1, now K will be positive 1, leading 1 plus row affected. So we are using this formula. Okay, right. So this first row we can write it back because it's not affected with the equations. Okay, so negative 2 times with 1 plus 2, we get 0. So negative 2, negative 3, negative 2, 2, 5, and then negative 2, 6, 1. Okay, and for the third row, so plus 0 plus negative 3 plus 0 plus 9. Okay. Right. So now our next focus will be this negative 3. Because our main part is we want to make the diagonal as 1. Diagonal should be 1. Right. So we want to make this element as 1. So back to the technique of ERO. So we want to make the element as 1. So we apply multiplication. Right. Okay. Apply multiplication if we want to make it as 1. So we multiply with the 1 over 3 R2. Okay. Right. Maybe we can write the formula as 1 with the number of the it's okay lah. Okay, you just need to know that we want to make it as 1. Right. Okay, so row number 1 and 3 we have to write it back. 9. Okay, so by using the formula 0, 1, negative 5 over 3, negative 1 over 3. Okay, so next our focus of element should be here, because after we get the leading one, so the element below the leading one should be 0. So we want to make it as 0. So what we need to apply is the technique of addition. Okay, so K, this one is negative 3, so K will be positive. Leading one at the row number 2 and the affected row. Okay, right. So row number 1 and row number 2 is not affected, so you have to write back lah. So 3, 0, 3, negative 5, and then 3, negative 1, 8. Okay. Right. So the last step is negative 5, because we want to make it as 1. So because we want to make it as 1, so we apply multiplication technique. So we multiply with 1, the value 5, row affected. Okay, so as you can see, if you apply multiplication, the value here will be similar to the one that we want to calculate. Like this one, negative 3, right? This one also negative 3. Negative 5, negative 5. Okay. So 1 and 2 is not affected, so you can write back. Okay, so 0, 0, 1, negative 8 over 5. Okay, now the diagonal is already 1. So now what you need to do is you need to apply back substitution. Back substitution, this column is for X, this column is for Y, and this is column for Z. Okay, now we focus at the third row. We only have the value of Z. So Z equal to negative 8 over 5. Okay, so now focus at the second column. We have the value of Y minus 5 over 3Z equal to negative 1 over 3. So Y is equal to negative 1 over 3 plus 5 over 3 multiply with Z, negative 8 over 5. So the answer is negative 3. And last one, the first row. So we have the value of X plus Y minus Z equal to 3. So X equal to 3 minus with X. Minus with X, so negative 8 over 5, and then plus Z is negative 3, so 8 over 5. Minus Y is 3, and then plus Z. Right. So 22 over 5. So this is your answer. X, Y, and Z. So you already get the answer by using the Gauss Elimination Method. Okay. Right. So so there is the drawbacks or the the problem when we apply the Gauss elimination method. So first, if we division by 0, if we have the division with 0, so it will be a problem because the answer will be infinity. So the other problem is the runoff error and the ill condition system. So because of these drawbacks, so we have one more method under elimination method, that is Gauss elimination with the partial pivoting. Okay, so for the partial pivoting, again you need to apply the ERO, elementary row operations, but now you have to reduce your matrix to the diagonal should be maximum number for each column. So the below one, below the diagonal should be 0. So this is the value. Okay, so for the Gauss elimination method, the diagonal should be 1. But for the partial pivoting, the diagonal should be maximum for each column. Okay, tapi the maximum must be in term of the absolute value. For example, we have 1, -4, 3. The other is A, B, C, D, E, F. Okay, so if we compare to this column, so we have to change the row to -4 BE, 1 AD, 3 C, F, because -4 will be maximum number, even though it's -4, but in terms of the absolute value 4, it will be 4. So that's why the second row or the -4 will be the maximum value. So you have to change the row. Okay, right. So let's try. So we have these questions. So let's try. So you have to put your matrix in terms of augmented matrix. Okay, right. So focus at the first column. Okay, first column. So each column, the value must be maximum. So if we compare 2, 4, and 3, 4 is the maximum. So what you need to do is you need to change row number 1 with the row number 2. If 1, 6, 2, -1, 1, 3, 2, 2, 15. Right. So after we get the value, after we get the maximum at the diagonal, so the below element should be equal to 0. Okay, should be equal to 0. So we apply the addition operation, but just now we use this formula K leading 1 plus row affected, but now we apply M leading 1 plus row affected. But this M means, let's say we want to make 2 as 0, right? So 2 will be divided by the maximum value. The maximum value means 2 divided by 4. Okay, so that one is positive, kan? So we make it negative. Okay, so here so M is equal to 2/4 negative 2/4 the maximum value plus row affected. Okay, And then the below one is negative 3 over 4, the maximum value plus row affected. Okay, so we are using this formula. Okay, so row number 1 is not affected. Okay, so negative 1 over 2 times with R1 plus R2 obviously become 0. So negative 1 over 2 times with 3 minus 1. So negative 5 over 2. And the other one is negative 1 plus 1, so 3 over 2. 6 plus with 4, 1. Okay. So the third row is negative 0. So R1 4 plus 3 obviously equal to 0 times with 3 and then plus with 2, negative 1 over 4. And then negative 1 plus with 2, 11 over 4. Six plus 15, 21 over 2. Okay. So now our focus is at the second column. For the second column, we have to choose the maximum value. But for the second column, you don't have to focus at these three values. If you want to choose the maximum value for the second column, you just focus at two values, these two values only. Negative 5 over 2 and also negative 1 over 4. Okay, you don't have to compare with the first column. We assume our first column is already satisfied. Okay, so now we have to decide which one is the maximum value, but you don't have to forget, you have to remember the value must be in absolute value. So means if we absolute these two value, obviously negative 5 over 2 will be the maximum. So you don't have to change the row lah. You just maintain. Okay. Right. So negative 5 over 2 already maximum. Yes, in terms of the integer, negative 1 over 4 will be the largest value, but we absolute the value. We absolute the value, so that's why negative 5 over 2 will be the maximum. Okay, so that one already maximum, so this one will be our next focus. We want to make it as 0, so make it as 0. So we need to find the value of m. So negative 1 over 4 divided by negative 5 over 2. So 1 over 10 lah. 1 over 10 but positive. So our value of m should be negative. So 1 over 10 the maximum value is at the row number 2 plus row affected. Okay, right. So column number, row number 1 and 2, you have to write back. Okay. 1 over 10 times with 0 obviously equal to 0 plus 0 equal to 0. So negative 1 over 10 multiply with negative 2.5 plus or negative 0.25. the answer will be 0. Okay, 3 over 2 and 5, and then plus with the 11 over 4. .6 or 13 over 5. The last one times with 1 and then multiply with the 21 over 2. 52 over 5. Okay, now you stop. Okay, now you stop. Okay, after that, what you need to do is you need to apply the backward substitution like just now. So this is column X, Y, and also Z. Focus at the third row. So we have 13 over 5 Z equal to 52 over 5. So Z equal to 52 over 13. So 52 divided by 13, answer is equal to 4. And then focus at the second row. So we have negative 5 over 2y plus 3 over 2z equal to 1. So y equal to 1 minus with 3 over 2z, and then times 2 divided by negative 5. So negative 2 over 5. Okay, nah. Negative 5. So 2. Yeah. Okay. And the last one, 4x plus 3y minus z equal to 6. So x is equal to 6 minus with 3y plus z 4 equal to 1. So this is your value x, y, and z. Actually, you can check your answer is either true or not. After you get the value of x, y, z, what you need to do is you substitute back into this equation. This one you have to put back lah. So you have to x minus y plus z equal to 4. 4x plus 3y minus z equal to 6. 3x plus 2y plus 2z equal to 15. So the value that you get x, y, z, you substitute into each equation to check. Let's say when you substitute the value x, y, z, and if you get the value similar to the 4, 6, and so 15, then your answer will be correct lah. Okay. So this is the technique how we want to solve the linear system, or we want to find the value of x, y, z by using the elimination method. I have one example here. Maybe you can try on your own, and this is the value. This is the answer.